Picture this: your fingers brush against cold stone as you step into a cavern untouched for centuries. The air is thick with the weight of forgotten stories, and the faint glow of your torch reveals something unexpected. A tool left behind by hands that shaped history in ways we're only beginning to grasp. This isn't just any relic. It's a piece of a puzzle that forces us to rethink everything we thought we knew about human innovation. Across the globe, hidden in the depths of caves, lie 24 abandoned tools so advanced, so baffling, they've redrawn the boundaries of what we believed possible in ancient times. These aren't mere artifacts, they're time capsules of ingenuity waiting to rewrite history. Why would such groundbreaking inventions be left behind? Were they lost in moments of crisis or deliberately hidden away? Each of these tools tells a story of civilizations that mastered technologies centuries, sometimes millennia before their time. From a crystal lens capable of magnifying the unseen to a bronze gear system that predates the Antikythera mechanism, these discoveries shatter the linear narrative of progress. They whisper of healers performing precise surgeries with obsidian scalpels, of navigators charting stars with bone dials, of artisans experimenting with electricity long before the modern era. These tools don't just fill gaps in history, they tear open entirely new chapters. So join us as we venture into the shadows of these cave systems, where the past refuses to stay buried. Together, we'll unravel the secrets of these 24 relics, each one a testament to the boundless creativity of humanity. This isn't just a journey through time. It's a revelation of how much we've underestimated our ancestors. By the end, you'll see history not as a straight line, but as a web of brilliance stretching across continents and epochs. The question isn't just what these tools were used for, it's what they reveal about the untapped potential of human innovation. Ready to uncover the mysteries? Let's begin. Caves are nature's vaults, silent guardians of humanity's oldest secrets. Unlike open-air sites weathered by time or cities rebuilt over centuries, caves offer a rare sanctuary where objects remain undisturbed, frozen in the moment they were left behind. Picture a clay pot placed in a crevice 3,000 years ago, still resting in the same spot, its contents untouched. Or a wooden tool preserved by the cool, stable humidity, its edges as sharp as the day it was carved. This remarkable preservation turns every cave into a time machine, offering us a direct line to the minds and hands of our ancestors. But why caves? For ancient peoples, these spaces were more than just shelters. They were workshops, sanctuaries, even libraries of knowledge. Some tools were hidden intentionally, perhaps by artisans safeguarding their trade secrets or communities stashing valuables during conflicts. Others were simply lost, dropped in the dark, and never recovered. What makes these finds so extraordinary isn't just their age, but the stories they carry. A chisel coated in resin tells us someone discovered how to reduce hand fatigue. A polished lens suggests an understanding of optics far ahead of its time. These aren't random objects, they're breadcrumbs leading us to forgotten chapters of human ingenuity. And then there's the mystery of abandonment. Why leave behind something so valuable? Some tools may have been outgrown, replaced by newer technologies, their old versions discarded like yesterday's gadgets. Others might have been ritual offerings placed in caves as gifts to spirits or gods, or perhaps their owners met sudden ends, their innovations buried with them. Whatever the reason, these abandoned tools force us to question the neat timelines of history. They remind us that progress isn't a straight path, It's a winding trail with branches cut short by time, disaster, or simply lost knowledge. What's equally fascinating is the global pattern. From the Andes to the Himalayas, caves on every continent have yielded tools that defy expectations. It's as if these hidden spaces were magnets for breakthroughs, drawing inventors and thinkers to experiment in their secluded depths. Maybe the quiet darkness sparked creativity, or maybe caves were the perfect places to test ideas away from prying eyes. Either way, they've become accidental archives safeguarding humanity's most audacious experiments. So when we step into a cave today, we're not just walking through rock, we're walking through a gallery of human potential. Every tool left behind is a clue, a challenge to our assumptions about what ancient people could or couldn't do. The deeper we dig, the more we realize how much history has yet to reveal. Buried beneath layers of dust in a Mediterranean cave, a palm-sized crystal disc sat undisturbed for 3,000 years. At first glance, it appeared to be nothing more than an ornate trinket, perhaps a ceremonial object or a wealthy trader's bauble. But when researchers held it up to the light, something extraordinary happened. The disc's carefully carved grooves bent sunlight into a focused beam, magnifying objects beneath it with startling clarity. This wasn't just a pretty artifact, it was a meticulously engineered lens, one that predates the earliest recorded optical tools by centuries. The implications are staggering. Who crafted this device and what were they trying to see? Some experts argue it could have been used by healers to examine wounds or remove splinters with precision. Others suggest artisans employed it for intricate work, engraving tiny patterns on jewelry or deciphering fine details in precious stones. Then there's the tantalizing possibility that it served as a primitive microscope, allowing ancient scientists to peer into a world invisible to the naked eye. Imagine the revelations that might have followed germ theory, cellular structures, or even microscopic life, all glimpsed millennia before modern science caught up. What makes this lens even more remarkable is the material itself. The crystal, likely quarried from rare deposits, would have been incredibly difficult to shape without modern tools. The precision of its curvature suggests a deep understanding of optics, knowledge we once believed was impossible for its time. Did this technology emerge from trial and error, or was it the product of a specialized school of craftsmen whose techniques were lost to history? The absence of similar finds hints that this lens might have been part of a larger, undiscovered toolkit, one that could rewrite the history of scientific innovation. And then there's the mystery of its abandonment. Why leave behind such a valuable object? Perhaps it was hidden during a conflict, its owner never returning to reclaim it. Maybe it was a prototype discarded when newer designs emerged. Or could it have been considered taboo, a tool too powerful, too revealing, and deliberately left in the dark? The cave's silence offers no answers, only the quiet hum of possibility. This crystal lens forces us to confront a humbling truth. Ancient civilizations were far more advanced than we've given them credit for. It's not just about the tool itself, but what it represents: a spark of curiosity, a relentless drive to see beyond the limits of the human eye. In that dim cave, someone held the power to magnify the unseen, to manipulate light, to push the boundaries of knowledge. And that changes everything. Deep in the rugged caves of the Balkans, a tarnished bronze fragment lay half-buried in the dirt for centuries, just another piece of scrap metal to the untrained eye. But when researchers carefully scanned the object and reconstructed it digitally, the truth emerged. This was no ordinary artifact. The fragment bore perfectly spaced teeth, designed to mesh seamlessly with other gears in a long-lost mechanism. The precision was astonishing, each tooth angled to transfer motion without slipping, a hallmark of advanced engineering. This wasn't just a broken relic, it was a single cog in what must have been an intricate machine, one that rivaled the complexity of the famed Antikythera mechanism. What's truly mind-bending is the age of this device. While the Antikythera mechanism dates back to ancient Greece, this Balkan gear fragment appears even older, pushing the timeline of sophisticated mechanical design further into the past. The craftsmanship suggests a level of metallurgical knowledge we didn't think existed at the time. Bronze, an alloy of copper and tin, is notoriously difficult to work with at this scale, too soft, and the teeth would wear down, too brittle, and they'd snap under pressure. Yet here was proof that someone, somewhere, had mastered the process. But what was this machine used for? The leading theory points to astronomy. Gears like these could have tracked celestial movements, predicting lunar phases or planetary alignments with startling accuracy. Imagine a handheld device operated by a simple crank that could tell farmers when to plant crops or sailors when to set sail, all based on the stars. Another possibility, navigation. The Balkans' rugged terrain and proximity to trade routes make it plausible that travelers relied on mechanical aids to chart their journeys. Then there's the esoteric angle. Some researchers propose the gear was part of a ritual object used in ceremonies to symbolize the turning of cosmic cycles. What's equally fascinating is what we don't know. This fragment was found alone, with no trace of the rest of the mechanism. Was the rest of the device dismantled and repurposed? Destroyed in a conflict, or is it still hidden elsewhere in the cave, waiting to be uncovered? The absence of similar finds only deepens the mystery. If this technology was widespread, where are the other examples? If it was rare, how did such specialized knowledge arise, and why was it lost? One thing's certain, this bronze gear shatters the myth that ancient societies were incapable of precision engineering. It forces us to reconsider the narrative of technological progress, suggesting that brilliance flourished in pockets we're only beginning to discover. Whoever crafted this gear didn't just understand mechanics, they pushed its limits, leaving behind a silent challenge to our assumptions about the past. And that's the real wonder of this find. It's not just a relic, but a question. What other mechanical marvels lie buried, waiting to rewrite history again? In the shadowed recesses of a Mesoamerican cave, archaeologists uncovered a blade so sharp it defied the centuries. A sliver of obsidian, its edges honed to a near-molecular edge. At first glance, it might seem like just another cutting tool, but under the microscope, the truth emerged. The blade's surface bore faint, parallel striations, not from carving wood or slicing rope, but from repeated contact with something far softer, human tissue. This wasn't a weapon or a craftsman's tool. This was a scalpel, and its discovery rewrites the story of ancient medicine. What makes this find so extraordinary isn't just its precision, but the traces left behind. Chemical analysis revealed residues clinging to the blade plant compounds known for their numbing properties. Imagine a healer, centuries before the Hippocratic Oath, applying herbal anesthesia before making an incision. This wasn't crude surgery. It was a calculated act of healing, blending sharpened stone with botanical knowledge. The implications are staggering. While ancient Greek physicians are often credited with pioneering medical techniques, this obsidian scalpel suggests Mesoamerican healers may have been performing equally sophisticated procedures, thousands of miles away and possibly much earlier. Obsidian itself is a marvel of nature, volcanic glass that fractures into edges sharper than modern steel scalpels. Even today, some surgeons use obsidian blades for delicate procedures, as they leave cleaner cuts and reduce scarring. But crafting such a tool without metal tools or magnification would have required extraordinary skill. Each strike to shape the blade had to be perfect. A single misstep could shatter the brittle material. Whoever made this scalpel wasn't just an artisan, they were a master of their craft, with an intimate understanding of anatomy and technique. Then there's the question of why it was left behind. Caves in Mesoamerica were often sacred spaces, linked to rituals and the afterlife. Was this scalpel part of a burial offering placed beside a revered healer? Or was it hidden during a crisis, its owner never returning to reclaim it? The cave's silence holds its secrets tight, but the tool's very existence challenges our assumptions. It hints at a world where medical knowledge was shared, refined, and perhaps even written down, though on perishable materials lost to time. This obsidian scalpel does more than cut through flesh. It cuts through history's assumptions. It forces us to reckon with the idea that advanced medicine wasn't the sole province of one civilization or era. Across oceans and epochs, humans sought to heal, to understand, to push the boundaries of what was possible. And sometimes they left their tools behind, waiting for us to find them and to listen. Tucked away in the damp recesses of an Appalachian cave, a humble-looking bone tool lay forgotten for millennia, until researchers noticed the faint grooves running along its surface, each one packed with traces of plant fibers. This wasn't just a worn-out implement, it was a key to unlocking one of humanity's oldest survival skills, the art of cordage weaving. Carbon dating revealed this tool to be 8,000 years old, pushing back the timeline of complex textile technology in North America by thousands of years. But what's truly remarkable isn't just its age, it's the sophistication it represents. The tool's design is deceptively simple. A series of precisely spaced notches allowed fibers to be twisted and braided into strong, uniform cords. Think of it as an ancient factory machine, but one operated by hand. These cords weren't just for tying things together, they were the backbone of early engineering. Picture nets strung across rivers to catch fish, ropes anchoring shelters against harsh winds, or even suspension bridges woven from vines and fibers, spanning gaps that would otherwise be impassable. This tool suggests a level of planning and resourcefulness we rarely associate with hunter-gatherer societies. What's even more fascinating is the material itself. Analysis of the plant fibers trapped in the notches reveals a deliberate selection process: some fibers for flexibility, others for strength, blended to create cords tailored for specific tasks. This isn't random experimentation, it's applied science, a mastery of materials that would eventually lead to everything from sailing ships to suspension bridges. And yet, this knowledge was nearly lost. The tool was abandoned, left in the cave as if its owner meant to return but never did. Was it hidden for safekeeping or simply forgotten in the rush of survival? The implications stretch far beyond the Appalachian Mountains. Similar tools have been found in Europe and Asia, hinting at a global network of innovation or perhaps parallel discoveries born of necessity. But this North American example stands out for its age, proving that complex textile technology wasn't imported. It was homegrown, a testament to the ingenuity of the continent's earliest inhabitants. And then there's the bigger question: why caves? These spaces weren't just shelters, they were workshops, classrooms, even libraries of tactile knowledge. The cool, stable environment preserved not just the tool, but the evidence of its use: the plant fibers, the wear patterns, the very fingerprints of its maker. It's as if the cave was waiting patiently for us to uncover the story hidden in those grooves. This bone-weaving tool does more than fill a gap in history. It rewires our understanding of progress. It reminds us that innovation isn't always about flashy inventions. Sometimes it's about the quiet mastery of everyday materials, the kind of brilliance that doesn't shout but endures. And in those notches, we find a thread connecting us to minds that thousands of years ago saw potential in a strand of fiber and turned it into something extraordinary. Hidden in the depths of a Middle Eastern cave, an unassuming clay jar sat undisturbed for over 2,000 years until archaeologists noticed something peculiar inside. A copper cylinder perfectly fitted to the jar's interior, surrounded by a mysterious crusty residue. At first, it seemed like just another ancient storage vessel. But when scientists recreated the setup and filled it with an acidic solution, grape juice or vinegar, substances readily available at the time, the jar did something extraordinary. It produced a small but measurable electric current. This wasn't a container, it was a battery. The implications are staggering. Long before Alessandro Volta invented the modern battery in the 18th century, someone in the ancient Middle East may have been harnessing electricity. The design is eerily simple yet effective. The copper cylinder acts as one electrode, while an iron rod, now corroded away, would have served as the other, suspended in the acidic electrolyte. Together, they could generate about 1 volt of electricity, not enough to power a light bulb, but sufficient for subtle, ingenious applications. So what was this ancient battery used for? One compelling theory points to electroplating, the process of coating one metal with another using an electric charge. Artisans could have used these jars to gild silver with a thin layer of gold, creating dazzling jewelry or ceremonial objects. Imagine a craftsman dipping a necklace into a solution, the battery's faint current bonding precious metals at a microscopic level. The result, objects that shimmered with otherworldly beauty, their craftsmanship inexplicable to those who didn't understand the secret behind them. Then there's the ritual angle. Ancient cultures often intertwined technology and spirituality, and electricity, mysterious, invisible, yet tangible, might have held sacred significance. Could these batteries have been used in temple ceremonies, delivering mild shocks to simulate divine contact? Or perhaps they powered primitive medical devices, their tingling current believed to have healing properties. The jar's discovery in a cave away from settlements hints at deliberate concealment, as if its knowledge was reserved for initiates or feared by the uninitiated. What's equally fascinating is the silence around this technology. If these batteries were widespread, why haven't we found more of them? Were they rare, their secrets guarded by a select few? Or were they abandoned when their makers vanished, their purpose fading into myth? The absence of written records leaves us guessing, but the artifact itself is undeniable proof of experimentation. This ceramic jar does more than challenge timelines. It rewires our understanding of ancient innovation. It suggests that curiosity about electricity isn't a modern phenomenon. It's a human one spanning millennia. And somewhere in that dark cave, someone left behind a clue, a silent spark waiting to reignite our imagination. What other electrical marvels might have been lost to time? The answer, like the current this jar produces, hums just beneath the surface of history. High in the thin air of the Himalayas, where snow clings to rock and time seems to stand still, a small stone cube rested undisturbed for millennia, until a glint of sunlight revealed its secret. This wasn't just a rock smoothed by nature. Its surfaces were polished to a mirror finish, each face etched with precise markings that matched the standardized weights of the ancient Indus Valley civilization. The implications are staggering. Here, in this remote cave, lay proof of a meticulously organized trade network stretching across mountains and rivers, one that depended on absolute precision. What makes this cube so extraordinary isn't just its craftsmanship, but what it represents: a system. The markings correspond to the Indus inch, a unit of measurement so consistent that weights from distant cities align perfectly. Imagine a merchant in a bustling Bronze Age marketplace, placing goods on one side of a scale, this stone on the other, and trusting the balance implicitly. No haggling over discrepancies, no suspicion of cheating. This was commerce built on mutual trust and shared standards, a concept we associate with modern globalization, not ancient history. The cube's precision raises tantalizing questions. Who oversaw this system? Was there a central authority certifying weights, or was the knowledge so ingrained that artisans could replicate it independently? The Indus Valley civilization left no deciphered written records, so this stone becomes a rare whisper of their bureaucratic brilliance. And why hide it in a cave? Perhaps it was a trader's safeguard stashed along a perilous route. Or maybe it was a master weight used to calibrate others, then retired to the shadows when newer systems emerged. Then there's the material itself. The stone isn't local, it was carried from miles away, chosen for its density and resistance to wear. Someone went to great lengths to ensure accuracy endured, even as empires rose and fell. That level of foresight hints at a society that valued fairness and order, one where commerce wasn't just about survival, but about sustaining connections across vast distances. But the cube's abandonment is the real mystery. Was it lost during a sudden flight from bandits or natural disaster, or deliberately left behind when the trade routes shifted, its purpose fading into obscurity? The cave gives no answers, only the silent testament of the stone itself, a perfect cube in an imperfect world, a reminder that even in antiquity, humanity sought harmony through measurement. And in those etched lines, we find a story not just of trade, but of trust chiseled into rock. Carved from the weathered rib of a whale, a palm-sized disc lay hidden in a Scandinavian cave for generations, its surface etched with delicate lines that seemed to dance in the flicker of torchlight. At first glance, it could pass for an ancient piece of art, but researchers soon realized these weren't random engravings. The lines formed precise angles, mirroring the paths of stars and the arc of the sun across the Arctic sky. This was no decorative trinket, it was a navigation tool, one that predates the Vikings' famed sunstones by centuries, proving that seafaring cultures mastered the art of celestial navigation far earlier than we ever imagined. What makes this bone dial so remarkable is its simplicity paired with staggering accuracy. By aligning specific notches with the horizon and tracking the movement of celestial bodies, a traveler could determine their latitude. Critical knowledge when navigating the open sea or traversing ice-locked fjords. Picture a lone explorer, perhaps a trader or hunter, holding the disc up to the weak Arctic sunlight, twisting it slightly to gauge their position. No compass, no maps, just bone and intuition honed by generations of observation. The dial's design suggests an intimate understanding of astronomy, passed down through oral tradition long before written records could preserve it. But here's the twist. This tool wasn't found near a coast or shipwreck, but deep in a cave far from any shoreline. Why? One theory suggests it belonged to a nomadic culture that migrated seasonally across ice and tundra, using the same techniques as sailors to traverse featureless landscapes. Another possibility, it was hidden deliberately, maybe by a navigator safeguarding his trade's secrets, or left as an offering to the gods of travel. The cave's isolation adds another layer of mystery. Was this a place of teaching, where apprentices learned to read the stars, or a vault for tools too valuable to risk losing at sea? The dial's material tells its own story. Whalebone, durable yet lightweight, would have resisted warping in freezing temperatures unlike wood or metal. And the choice of a sea creature's remains feels poetic, as if the very bones of the ocean were guiding those who dared to cross it. This wasn't just technology, it was symbolism woven into function, a reminder that ancient innovators didn't separate practicality from reverence. Perhaps most humbling is the realization that this dial isn't an anomaly. Similar artifacts, though rare, have surfaced across the Arctic, hinting at a shared system of knowledge that spanned continents. These navigators didn't need magnetic compasses or GPS. They had something arguably more profound, a dialogue with the cosmos etched into bone and memory. And in that quiet cave, one of their tools waited patiently, a silent testament to humanity's relentless drive to explore, to map the unmappable, to find direction even in the darkest of nights. Buried in the cool darkness of a French cave, a flat flint slab lay forgotten for millennia until researchers noticed its surface wasn't weathered by time, but meticulously carved with a network of shallow, interconnected channels. At first glance, the pattern seemed decorative, perhaps ritualistic, but the precision of the grooves told a different story. These weren't random scratches. They formed a deliberate geometric grid, eerily reminiscent of modern circuit boards. The discovery sparked a tantalizing question. Could this flint slab be more than art? Could it be a functional tool, a prehistoric blueprint for technology we thought was millennia away? What sets this artifact apart is its purposeful design. Unlike symbolic cave art, which often flows with organic curves, these channels are rigid and angular, intersecting at exact points like pathways meeting at junctions. Some researchers propose the grooves served a practical role, perhaps guiding liquids for rituals or even early scientific experiments. Picture dye poured into one end, branching through the network to form predictable patterns, a primitive form of fluid dynamics. Others suggest the slab acted as a territorial map, its channels tracing rivers, trails, or hunting routes shared between generations. But the most intriguing theory, that it represents an abstract understanding of connectivity, a physical manifestation of systems thinking the same logic that underpins circuitry today. The material itself adds another layer of intrigue. Flint, prized for its ability to hold sharp edges, was the steel of the Stone Age. Yet here, it wasn't being used to cut or pierce, but to channel and direct. This repurposing hints at a cognitive leap, seeing stone not just as a tool, but as a medium for encoding information. The depth of each groove is consistent, suggesting the use of a specialized engraving tool, possibly one made of bone or hardened wood. And the wear patterns indicate repeated use, as if the slab was referenced often, its pathways traced by fingers or tools over years. Then there's the mystery of its abandonment. Why leave behind something so painstakingly crafted? Caves in this region were often gathering places where knowledge might have been shared or stored. Was the slab a teaching aid left behind when its keepers moved on, or did its function become obsolete, replaced by newer methods of record keeping? The absence of similar finds makes this artifact an enigma. If it was part of a broader technological tradition, where are the other examples? If it was a one-off creation, what inspired such innovation? This flint slab forces us to reconsider the boundaries between ancient and modern thinking. Its design echoes the logic of circuits, not because its makers understood electrons, but because they grasped a fundamental truth. Complexity can be broken into pathways, and connections hold power. Whether it guided liquids, mapped landscapes, or symbolized something deeper, it stands as a testament to humanity's timeless drive to organize, to systematize, to make sense of the world through patterns. And in those carved channels, we find a whisper across time, a reminder that innovation isn't always about new materials, but new ways of seeing what's already in our hands. Deep in the humid darkness of an Indonesian cave, a team of archaeologists brushed away centuries of sediment to reveal an object that shouldn't exist, a fossilized wooden wheel, its rim carved with a perfect groove. At first glance, it might resemble a broken cartwheel, but the truth was far more revolutionary. This was a pulley, a simple machine that transforms force, allowing a single person to lift weights far beyond their strength. And its existence here, preserved in petrified wood, appends everything we thought we knew about the timeline of engineering. The discovery is baffling because pulleys were long believed to be the hallmark of complex societies. Think ancient Egyptians hoisting pyramid stones or Greek architects building temples. Yet this Indonesian pulley predates those civilizations by centuries, if not millennia. The wood itself tells a story of astonishing preservation, fossilized by minerals seeping through the cave walls, locking its shape in stone. The groove along its edge shows minimal wear, suggesting it was used sparingly, perhaps for extraordinary projects before being abandoned or hidden away. But what could a society this ancient have been lifting? One theory points to megalithic structures scattered across the region, massive stone tombs and monuments whose construction has puzzled historians for generations. Without metal tools or beasts of burden, how did these cultures maneuver multi-ton stones into place? This pulley offers a clue. A simple wooden wheel anchored to a frame could have redirected ropes to distribute weight, turning impossible tasks into feats of collective effort. Imagine teams of workers chanting in unison as they guided massive slabs into position, their strength multiplied by this unassuming technology. The pulley's design hints at even deeper sophistication. The groove isn't just a rough notch, it's smooth and symmetrical, engineered to reduce friction on the ropes. That level of precision implies iteration. Someone didn't just invent the pulley on a whim. They refined it, tested it, and understood its physics long before Newton's laws were penned. And the choice of wood is telling. In a tropical climate where metal corrodes, wood was the perfect material, durable enough to bear weight, yet lightweight enough to transport and modify. Then there's the mystery of its abandonment. Why leave behind such a vital tool? Perhaps it was part of a temporary structure, dismantled when the work was done. Or maybe it was a prototype replaced by newer designs lost to time. The cave's isolation raises another possibility. Was this pulley part of a sacred or secret project, its knowledge guarded by a select few? Without written records, we're left to piece together the story from the artifact itself, a silent witness to ingenuity that challenges our assumptions about progress. This petrified pulley does more than defy timelines. It redefines what we consider primitive. It's a reminder that innovation isn't confined to the so-called advanced civilizations of history. Across the globe, in caves and jungles and forgotten villages, people solved problems with brilliance we're only beginning to uncover. And sometimes they left their tools behind, not as trash but as time capsules, waiting for us to recognize the mastery hidden in their grooves. Stuck to the walls of a Greek cave like some ancient industrial accident, a strange metallic paste clung stubbornly to a set of bronze tools. At first, researchers assumed it was just corrosion, until chemical analysis revealed something extraordinary. This wasn't rust or decay, it was a deliberately formulated adhesive, a blend of copper, tin, and rare mineral oxides that created a heat-resistant bond stronger than anything seen from that era. The paste could withstand temperatures high enough to melt ordinary glues, suggesting its makers weren't just crafting, they were engineering for extreme conditions. What's truly remarkable is how this ancient adhesive mirrors modern soldering techniques. Today, we use metallic alloys to fuse components in electronics or plumbing, relying on precise chemical formulas to ensure durability under stress. Yet here was proof that someone, over 2,000 years ago, had stumbled upon a similar solution. The inclusion of rare minerals like malachite and cassiterite wasn't accidental. These compounds lower melting points and improve flow, just as flux does in contemporary soldering. This wasn't trial and error. It was applied chemistry, a recipe refined through experimentation. So where would such an advanced adhesive have been used? One compelling theory points to shipbuilding. The Aegean Sea was a hub of maritime trade, and wooden hulls reinforced with metal fittings would have needed waterproof, heat-resistant bonds to withstand the punishing Mediterranean sun and salt water. Picture artisans applying this paste to seal joints or anchor nails, creating vessels sturdy enough for long voyages. Another possibility, weaponry. Bronze swords and armor required seamless joins to avoid weak points in battle. A glue that could endure the heat of forging would have been a military game-changer, turning ordinary blades into masterpieces of durability. But the real mystery isn't just its use, it's its abandonment. Why was this technology lost? Unlike stone tools or pottery, metallurgical knowledge often vanished when civilizations collapsed, taking trade secrets to the grave. Perhaps the recipe was guarded by a guild of smiths, their expertise disappearing when political upheaval scattered them. Or maybe newer, cheaper methods replaced it, rendering the paste obsolete. The cave's isolation adds another layer of intrigue. Was this a workshop hidden away for secrecy, or a stash meant to be reclaimed and never was? This metallic adhesive does more than fill gaps in history, it bridges them. It's a tangible link between ancient craftsmanship and modern engineering, proving that the drive to solve problems with chemistry and creativity is timeless. And in that sticky, stubborn residue, we find a reminder: some innovations are so effective, they're rediscovered centuries later, not because they were forgotten, but because they were always waiting to be understood anew. High in the Andes, where steep cliffs and echoing valleys make even shouts vanish into thin air, a hollowed-out animal horn lay hidden in a cave for centuries until someone noticed its unusual shape. Unlike ordinary hunting horns, this artifact had a carefully carved interior chamber, designed not just to produce sound but to shape it. When researchers blew into it, the horn didn't just bellow, it amplified specific frequencies with eerie precision, turning whispers into resonant calls that could carry for miles. The genius of this horn lies in its acoustics. The inner spiral acts like a natural sound filter, boosting certain tones while dampening others. Blows softly, and it mimics the deep grunt of a wild deer, perfect for luring game. Adjust the pressure, and the pitch rises to a piercing cry, audible across canyons. This wasn't just a noisemaker, it was an ancient amplifier, a tool honed by generations who understood the physics of sound long before the word acoustics existed. But was it used for hunting, communication, or something more? In the Andes, where communities were scattered across treacherous terrain, such a horn could have been a lifeline. Picture a shepherd stranded by a rockslide, blowing a distress signal that echoes from cliff to cliff, or hunters coordinating a drive, using animal calls to steer prey toward waiting traps. There's also the spiritual angle. Similar horns appear in rituals across indigenous cultures, their voices believed to carry messages to the spirit world. The cave's location, remote yet central to ancient trade routes, hints that this horn might have served multiple roles, blurring the line between practicality and ceremony. What's equally fascinating is the material. The horn isn't from a domesticated animal, but a wild species like a guanaco or deer, chosen for its natural resonance. The craftsmanship suggests deep knowledge of animal anatomy, not just which bones to hollow, but how to shape them to manipulate sound waves. And the wear marks inside reveal decades of use, as if this tool was passed down, its techniques taught from one generation to the next. Yet its abandonment raises questions. Was it lost during a migration, or deliberately placed in the cave as an offering? The absence of similar finds makes it a rarity, a glimpse into a technology that might have been widespread or reserved for specialists. Either way, this horn shatters the stereotype of ancient people as technologically primitive. They didn't just live in harmony with their environment, they reverse-engineered it, turning a simple animal bone into an instrument of survival and connection. And in its echoes, we hear something timeless, the human urge to bridge distances, to be heard, to turn the raw materials of the earth into something extraordinary. Among the shards of broken pottery scattered across the floor of an Egyptian cave, one shattered clay vessel stood out not for its shape, but for its ghostly inner sheen. When researchers pieced it together, they uncovered a revelation. The pot's interior was lined with a thin layer of glass, fused seamlessly to the clay. This wasn't accidental vitrification from a fire. It was deliberate engineering, a high-tech solution crafted thousands of years before glassmaking became widespread. And its purpose, to withstand temperatures so extreme they could liquefy metal, turning this humble pot into a furnace capable of forging the future. The brilliance of this crucible lies in its layered design. Ordinary clay would crack under the stress of repeated heating and cooling, but the glass lining acted like a thermal buffer, expanding and contracting without fracturing. This allowed artisans to work with metals like gold and copper at their melting points exceeding 1000 degrees Celsius without destroying their tools. Think of it as the ancient equivalent of a modern lab's refractory crucible, the kind used today in aerospace or semiconductor manufacturing. The implications are staggering. Someone in pre-dynastic Egypt wasn't just melting metal. They were pushing the boundaries of material science, creating tools that could handle the heat of progress. But here's the puzzle. Glass production on this scale wasn't supposed to exist yet. The earliest known glass workshops date to around 1500 BCE, but this crucible is centuries older. So where did the glass come from? One theory suggests it wasn't made from scratch, but repurposed from rare natural glass like Libyan desert glass, formed when meteorites struck the Sahara's sands. Another possibility, this was a fleeting technological peak, a secret method lost when its makers died or their society collapsed. The cave's isolation hints at guarded knowledge. Perhaps only a select few knew the recipe, and with them it vanished. What's equally fascinating is what this crucible might have been used for. The residue inside contains traces of copper and arsenic, a blend used to harden tools and weapons. This wasn't just about adornment, it was about survival. Imagine a smith in that cave, pouring molten bronze into molds for axes or chisels, each pour made possible by this glass-lined marvel. Or consider the ritual angle. In a culture where metals held divine significance, perhaps this crucible was reserved for crafting sacred objects, its heat seen as a bridge between earthly and celestial realms. Yet its abandonment raises haunting questions. Was it left behind during a hasty flight from invaders, destroyed to protect its secrets, or simply worn out, its innovation forgotten when newer methods emerged? The shattered pieces offer no answers, only a silent challenge to our assumptions. This crucible doesn't just rewrite the history of glass, it redefines what we thought possible in the hands of ancient innovators. And in those glazed fragments, we catch a glimpse of a world where brilliance flickered, bright and brief, before being swallowed by the sands of time. Carved from the rib of an ancient buffalo, a slender bone rod lay hidden in a Central Asian cave for millennia, its surface marked with a series of precise notches that seemed too orderly to be random. At first glance, it might resemble a simple tally stick, perhaps counting livestock or trading goods. But when researchers mapped the markings against lunar cycles, a stunning pattern emerged. Each groove aligned perfectly with the phases of the moon, turning this humble artifact into something extraordinary, a portable astronomical calculator, one that didn't just track time but might have predicted eclipses with uncanny accuracy. What makes this rod so remarkable is the sophistication hidden in its simplicity. Nomadic cultures, often dismissed as too mobile for complex science, couldn't rely on stationary observatories like Stonehenge or Babylon's ziggurats. Instead, they carried the cosmos in their hands. Picture a herder under the vast steppe sky, consulting this bone rod to know when the moon would wax or wane, critical knowledge for rituals, migrations, or even breeding cycles of animals. But the deeper genius lies in the spacing of the notches. Some clusters correspond to the 18-year Saros cycle, a pattern of recurring eclipses known to modern astronomers. If intentional, this means ancient skywatchers didn't just observe celestial events, they anticipated them, turning patterns into prophecy. The material itself tells a story of resilience. Bone, lightweight yet durable, could survive the jostling of life on the move, unlike fragile clay tablets or parchment. The markings show wear from frequent handling, as if this tool was passed between generations, its secrets whispered around campfires. And the precision of the grooves suggests specialized craftsmanship, perhaps the work of a shaman or astronomer, their role as vital to survival as hunters or healers. But why abandon such a vital tool? One theory points to cultural upheaval. Nomadic societies rarely left permanent records, and their knowledge often vanished when tribes dispersed or assimilated. This rod might have been lost during a sudden migration, or deliberately hidden to protect its secrets from rivals. The cave's location, near a seasonal gathering site, hints it could have been a teaching aid, left behind when its keepers moved on. This bone rod does more than mark time. It shatters stereotypes. It proves that scientific curiosity isn't bound by stone temples or written scrolls. Sometimes the greatest breakthroughs fit in the palm of a hand, etched into bone by those who read the sky like a map. And in those notches, we find a legacy far older than we ever imagined, a testament to humanity's endless quest to unravel the mysteries above. Buried in the dry stillness of a North American cave, a peculiar stone tube lay half-covered in dust, its surface worn smooth not by chance, but by deliberate, repeated motion. At first glance, it might resemble a broken pipe or a ceremonial object, but the truth is far more ingenious. This hollow drill bit, carved from durable sandstone, bears spiral grooves along its interior, a telltale sign it was designed to rotate at high speed, powered by a bowstring wrapped around its shaft. And its purpose, to extract pristine core samples from stone or wood, a technique so advanced we once believed it was invented millennia later by industrial societies. The mechanics of this tool reveal a level of sophistication that defies its age. When the bowstring is pulled back and forth, the drill spins rapidly, its hollow center allowing a cylindrical core to remain intact as the outer material is ground away. Think of it as the Stone Age equivalent of a modern coring drill, the kind used today to sample ice layers in Antarctica or extract mineral deposits. But this wasn't just for curiosity. Core sampling was essential for practical survival. Miners could assess the quality of stone before quarrying, avoiding wasted effort on brittle or flawed material. Builders might have used it to test timber strength or create precise dowels for joining wood without nails. Even artisans could have extracted uniform plugs of obsidian or flint for crafting arrowheads or jewelry. What's truly groundbreaking is the implication. This technology predates metal tools by centuries. Without iron or bronze, ancient craftsmen harnessed friction, physics, and patience to achieve results we'd struggle to replicate today. The drill's design isn't crude, it's optimized. The slight taper at the tip reduces binding, while the grooves channel debris away, preventing clogging. This isn't a prototype, it's the product of generations of refinement, a tool honed to perfection through trial and observation. Yet the mystery of its abandonment lingers. Why leave behind such a versatile tool? Perhaps it was part of a specialized kit cached in the cave for a future project that never came to pass. Or maybe its secrets were so closely guarded that when its makers vanished, the knowledge vanished with them. The cave's location, near ancient trade routes, hints it could have been a workshop for itinerant craftsmen, their tools left behind when seasons or societies shifted. This hollow drill bit does more than fill a gap in history. It bores straight through our assumptions. It proves that innovation isn't about having the right materials. It's about seeing the potential in what's at hand. And somewhere in that quiet cave, someone left behind not just a tool, but a challenge to reconsider what ancient hands were truly capable of. Nestled in the damp stillness of a Japanese cave, a seemingly ordinary stone chisel lay concealed for thousands of years, until someone noticed the strange, glossy substance coating its handle. At first glance, it might have been mistaken for tree sap or decay, but analysis revealed something far more deliberate. This was no accident of nature. It was an engineered solution, a plant-based resin carefully applied to cushion the tool's grip and absorb the punishing shock of each strike. What makes this discovery revolutionary isn't just the resin itself, but what it represents. A leap in ergonomic design so advanced, it wouldn't be matched until the rubberized handles of modern power tools. The genius of this chisel lies in its hybrid construction. The stone blade, sharp and unyielding, was lashed to a wooden haft, but where bare wood would splinter or bruise the user's palm, this tool boasted a resilient resin wrap. Microscopic analysis shows the resin was mixed with fibrous plant matter, creating a composite material that flexed under pressure without cracking. Think of it as a prehistoric version of vibration dampening technology, the kind that today's construction workers rely on to prevent joint damage after hours of drilling or hammering. Yet here it was, perfected by hands that shaped stone and wood long before metal became commonplace. But why go to such lengths? The answer lies in the demands of daily survival. Japan's ancient Jomon people were master woodworkers, crafting everything from intricate lacquerware to sturdy boats. A tool that reduced hand fatigue meant more hours of precision carving, more efficient building, less pain at the end of a long day. This wasn't just about comfort, it was about productivity and longevity, a recognition that the body itself was a tool to be preserved, and the resin's composition reveals even deeper knowledge. Samples indicate it was harvested from local trees at specific times of year, when the sap's elasticity was ideal proof that these artisans understood seasonal material properties in ways we're only beginning to appreciate. The chisel's abandonment is its own mystery. Found in a cave far from any known settlement, it might have been part of a mobile craftsman's kit, left behind during a hasty retreat or hidden for safekeeping. Or perhaps it was a prototype, its innovation never widely adopted before being lost to time. The silence of the cave offers no answers, only the quiet testament of the tool itself. A relic of ergonomic brilliance that forces us to reconsider the boundaries between ancient and modern ingenuity. What's most humbling is the realization that this chisel isn't an outlier. Similar resin-reinforced tools have been found across Southeast Asia, suggesting a shared understanding of material science that spanned continents. These weren't isolated flashes of brilliance, but part of a broader tradition, one that viewed tools not just as extensions of the hand, but as partnerships between human and natural engineering. And in that sticky, ancient resin, we find a truth both simple and profound. Innovation isn't always about inventing something new. Sometimes it's about listening to the wisdom of the body and letting the materials at hand whisper their solutions. Deep in the rocky embrace of a Turkish cave, a stone rod lay half buried in the dirt, its surface carved with a continuous spiral groove so precise it seemed machined. At first glance, it might pass for a ritual object or decorative pillar, but the truth was far more revolutionary. This was a threaded bolt, its grooves designed to twist perfectly into a matching stone socket, creating a mechanical bond stronger than any simple peg or wedge. And its existence here, centuries before Archimedes famously described the principles of screw mechanics, forces us to rewrite the history of engineering. The sophistication of this bolt lies in its geometry. Each groove follows a consistent pitch, meaning the distance between threads is uniform along the entire length, a feat requiring meticulous measurement and carving. When paired with its socket, the bolt doesn't just hold, it distributes weight evenly, resists lateral forces, and can even be adjusted for tension. Think of it as the ancient ancestor of modern screws, the kind that hold everything from furniture to spacecraft together. Yet here it was, crafted from stone, a material far harder to shape with such precision than metal. The maker would have needed specialized tools, perhaps copper or bronze chisels, and an intimate understanding of rotational motion. This wasn't guesswork, it was applied physics carved into rock. But what could such a bolt have been used for? One compelling theory points to construction. The cave sits near the ruins of an ancient settlement, where stone foundations show signs of advanced masonry. A threaded bolt could have anchored beams or secured roof slabs, creating structures capable of withstanding earthquakes, a constant threat in this seismically active region. Another possibility, it was part of a larger machine, maybe a press for olives or grapes, where controlled pressure was essential. The threads would have allowed gradual, even force, turning brute strength into precision work. Then there's the cultural context. The screw thread wasn't just a practical innovation, it was a conceptual breakthrough. Unlike nails or ropes, which rely on friction or tension, a threaded connection harnesses the power of rotation, a principle that underpins everything from water pumps to assembly lines. The fact that someone in this region grasped that principle so early suggests a level of abstract thinking we rarely associate with prehistoric societies. Yet the bolt's abandonment is a puzzle. Why leave behind something so valuable? Perhaps it was a prototype discarded when a newer design emerged, or maybe it was part of a sacred structure left in the cave as an offering. The absence of similar finds only deepens the mystery. If this technology was widespread, why haven't we found more examples? If it was unique, what inspired its creation, and why did it vanish? This stone bolt does more than connect two pieces of rock. It bridges eras. It's a testament to the timelessness of ingenuity, proving that the seeds of modern engineering were planted far earlier than we ever imagined. And in those spiral grooves, we find a silent challenge to reconsider what ancient hands and minds were truly capable of. Hidden in the dense jungle near the Amazon, a flat stone slab sat undisturbed for centuries, its surface etched with shallow, parallel grooves that at first seemed like nothing more than natural weathering. But when researchers examined it under ultraviolet light, the truth emerged. Those grooves weren't random. They were designed to grind and mix minerals into pigments so vibrant, they still retained their brilliance after thousands of years. This wasn't just a grinding stone, it was a prehistoric paint factory, producing colors that put modern synthetic dyes to shame. What sets this pigment mill apart is the sophistication of its chemistry. Analysis of the residues trapped in those grooves reveals a palette of reds from iron oxides, deep blacks from manganese, and startling blues derived from rare Amazonian clays, each one stabilized with plant-based binders that prevented fading. These weren't just crushed rocks, they were engineered compounds formulated to resist humidity, sunlight, and time itself. Picture an artisan kneeling over this slab, patiently grinding minerals with a smooth river stone, adding drops of tree sap or oils to create the perfect consistency. The result, paints that could adorn ceremonial masks, textiles, or cave walls with colors so enduring, they outlasted the civilizations that made them. But here's the real marvel. Some of these pigments have no known natural sources nearby. The lapis-like blues, for instance, match mineral deposits hundreds of miles away, suggesting trade networks far more extensive than we ever imagined. This slab wasn't just a tool, it was evidence of a connected world where materials and knowledge traveled vast distances long before roads or written language. And the choice of minerals reveals even deeper insight. Certain colors were reserved for specific purposes: ochres for sacred art, blacks for tattooing, shimmering micas for body adornment, each hue carrying cultural meaning as rich as its chemical composition. The mill's design is equally ingenious. The grooves aren't uniform, they vary in depth and angle to accommodate different grinding techniques. Some are wide and shallow for coarse crushing, others narrow and deep for fine powder. This wasn't a one-size-fits-all tool. It was a versatile system capable of producing everything from thick paste to delicate washes. Where patterns suggest it saw daily use, perhaps passed down through generations, its surface smoothed by countless hours of labor. And the cave's location near a river junction hints at a workshop frequented by traders or pilgrims, a place where knowledge and materials converged. Yet its abandonment raises questions. Why leave behind something so vital? Unlike pottery or weapons, pigments were a renewable resource. Why not take the knowledge elsewhere? One theory points to cultural collapse. Perhaps the society that perfected these techniques dispersed under pressure from invaders or environmental shifts. Another possibility, the pigments themselves held spiritual significance, tied to rituals or taboos that made them inseparable from the cave's sanctity. Whatever the reason, this silent slab speaks volumes about a people who saw color not just as decoration, but as language, a way to encode identity, belief, and memory in strokes of enduring brilliance. What's most humbling is realizing how little we've actually advanced. Today's industrial dyes, for all their synthetic complexity, often fade faster than these ancient hues. In those carefully carved grooves, we find a challenge to our assumptions about progress, and a reminder that sometimes the most enduring innovations come not from labs, but from the patient alchemy of hands, earth, and time. Buried beneath layers of sediment in an Ethiopian cave, a simple stone beam lay balanced across a central fulcrum, its surface worn smooth by centuries of use. At first glance, it might resemble a child's seesaw or a crude lever, but the truth was far more profound. This was a precision scale, its design so exact that the slightest weight difference could tilt the beam. Beside it sat a set of polished stone weights, each one matching a standardized system found hundreds of miles away. Together, they formed a revelation. Prehistoric Africa wasn't just trading goods, it was measuring them with an accuracy that rivals modern markets. The brilliance of this scale lies in its silent testimony to a regulated economy. The weights, carved from dense basalt, aren't arbitrary. They follow a strict ratio, with smaller units combining to match larger ones, proof of a shared measurement system across vast distances. Imagine a trader in this cave, carefully balancing nuggets of gold or bags of grain against these certified stones, ensuring fairness in exchanges that might span deserts and mountains. This wasn't barter, this was commerce with rules, a network where trust was built on uniformity, and the scale's sensitivity is staggering. Replicas show it could detect differences as slight as a few grams, a level of precision that suggests these weren't just tools for casual trade, but instruments for high-value transactions, perhaps even taxation or tribute. But who enforced these standards? The absence of written records leaves us guessing, but the scale's location offers clues. Ethiopia's highlands were a crossroads, linking the Nile Valley to the Red Sea and beyond. A centralized authority, perhaps a kingdom or a coalition of merchants, might have mandated these weights to streamline trade, much like the shekel of Mesopotamia or the deben of ancient Egypt. Yet this system predates those by centuries, hinting at an African innovation that influenced later civilizations. The stones themselves tell another story. Their wear patterns reveal decades of use, as if this cave was a bustling hub where goods were weighed and deals struck under the watchful eye of a trusted mediator. What's equally fascinating is what was being traded. Residue analysis on the weights hints at traces of rare commodities, specks of myrrh resin, flecks of copper oxide, even fragments of obsidian from distant volcanic fields. These weren't everyday goods, they were luxuries, the kind that spurred the first long-distance trade networks. The scale's precision suggests a society that valued not just abundance but equity, a culture where fairness was etched into stone. Yet its abandonment whispers of a mystery. Why leave behind such a vital tool? Perhaps the trade routes shifted, bypassing this cave as new hubs emerged. Or maybe conflict disrupted the networks, rendering the weights obsolete. The cave's isolation adds another layer. Was this scale hidden during a crisis, its owners planning to return? Or was it a relic of a system that collapsed when the ties binding these ancient economies frayed? This balanced scale does more than measure weight. It weighs our assumptions about the past. It proves that commerce wasn't born in grand cities alone, but in the quiet corners of caves like this one, where hands will never know grasped the true value of fairness and carved it into stone. In the silent depths of a Maltese cave, a limestone disc no larger than a dinner plate lay half buried in the earth, its surface punctuated by a series of perfectly spaced holes. At first glance, it might resemble an ancient game board or decorative object, but when researchers suspended it from a cord and set it spinning, the stone came alive with an eerie, melodic hum. Each hole, precisely positioned, altered the airflow to produce distinct harmonic tones, transforming this unassuming disc into what might be history's oldest known musical instrument. And the intervals between those tones weren't random. They matched the mathematical ratios of a musical scale, proving that whoever crafted this stone understood the physics of sound centuries before Pythagoras formalized the rules of harmony. The genius of this sound stone lies in its dual nature: part instrument, part scientific tool. The holes aren't merely decorative, their diameters and spacing create controlled vibrations, much like the finger holes of a flute or the slots in a wind chime. Spin it slowly and the tones blend into a soothing drone. Increase the speed and the pitches separate into clear intervals, perfect fourths and fifths, revealing an intentional design tuned to the human ear. This wasn't accidental artistry, it was acoustic engineering carved into rock. The implications are staggering. If this disc was used in rituals, it suggests ceremonies where sound itself was sacred, where the spinning stone might have summoned spirits or altered states of consciousness through rhythmic repetition. Alternatively, it could have been a teaching tool, demonstrating harmonic principles to apprentices in a world without written notation. What's equally fascinating is the material choice. Limestone, abundant in Malta's cliffs, has unique resonant properties, dense enough to sustain tones but porous enough to prevent dull overtones. The disc's thickness varies subtly, thinning toward the edges to enhance vibration, a detail that would require meticulous carving and testing. Wear patterns near the holes suggest frequent use, as if this object was handled for generations, its secrets passed down through touch and sound rather than words. Yet the mystery of its abandonment lingers. Why leave behind something so extraordinary? Malta's ancient temples are riddled with clues about sound-based rituals, echoing chambers, niches that amplify whispers hinting at a culture obsessed with acoustics. Perhaps this disc was part of a larger ensemble, hidden when invaders threatened or when beliefs shifted. The cave's isolation adds another layer. Was this a sacred space where only initiates could commune with these harmonics, or a workshop where prototypes were tested and discarded? This perforated stone does more than make noise. It bridges the gap between art and science, between the tangible and the ephemeral. In its spinning whir, we hear an ancient desire to harness the invisible, to turn motion into music, and to encode mathematical beauty into something as enduring as stone. And in that timeless hum, we find a question: how many other forgotten instruments lie silent, waiting for the right hands or the right wind to bring them back to life? Buried in the volcanic soil of an Oceania cave, an axe head rested for centuries, its stone blade seemingly ordinary, until someone noticed the intricate web of fibers binding it to the handle. This wasn't just rope or random lashing. It was a deliberate reinforcement technique, a woven lattice of plant fibers layered with resin to create a shock-absorbent buffer between stone and wood. The result, a tool that could withstand repeated impact without splitting its handle, a problem that plagues even modern axes. What seems like a simple innovation is actually a stroke of material science genius, an ancient answer to a challenge engineers still grapple with today. The secret lies in the fiber's composition. Microscopic analysis reveals strands from coconut husk and pandanus leaves, chosen for their tensile strength and flexibility. These weren't just tied haphazardly, they were woven in a crosshatch pattern, distributing force evenly across the handle. The resin, likely derived from local tree sap, acted as both adhesive and dampener, absorbing vibrations that would otherwise travel into the user's arms. Think of it as the Stone Age equivalent of the carbon fiber or fiberglass used in modern tool handles, materials prized for their ability to combine strength with shock absorption. Yet here it was, perfected by hands working with nothing but natural resources and observational wisdom. But why go to such lengths? The answer is written in the wear patterns. Oceania's dense rainforests and hardwoods demanded tools capable of relentless chopping. A splintered handle wasn't just an inconvenience. It could mean starvation if a vital canoe or shelter project stalled. This axe wasn't a ceremonial object, it was a daily workhorse, its fiber wrapping showing signs of repair and reinforcement over years of use. The craftsmanship suggests this wasn't a one-off experiment, but a refined technology passed down through generations. What's truly groundbreaking is the mindset it reveals. These artisans didn't just use materials, they engineered them. By combining rigid stone with flexible fibers, they created a composite material stronger than the sum of its parts. It's a principle that defines everything from reinforced concrete to bulletproof vests today. Yet in this cave, it lay hidden, a testament to a lineage of makers who understood synergy long before the word entered scientific vocabularies. The axe's abandonment poses its own questions. Was it left behind during a sudden migration, or cached for a future return that never came? The cave's location, perched above a now-vanished settlement, hints at a storage place for prized tools, perhaps safeguarded from storms or raids. Or maybe it was retired, its fibers frayed beyond repair, left as an offering to the spirits of craft and forest. This fiber-wrapped axe does more than cut wood, it cuts through time. It reminds us that the most enduring innovations often arise from necessity's forge, where every splintered handle teaches a new way to weave resilience. And in those silent fibers, we find a thread connecting ancient ingenuity to the very heart of modern design. Tucked away in the shadows of a Mesopotamian cave, a pair of clay halves lay nestled together, not broken pottery, but something far more revolutionary. When archaeologists carefully separated the two pieces, the truth became clear. This was a precision mold, its interior carved in the negative shape of a blade, designed to pour molten metal into a cavity and produce perfect, identical copies. But what makes this discovery extraordinary isn't just its age, it's the sophistication of its engineering. The mold seems aligned with millimeter precision, and tiny channels along the edges allowed air to escape as liquid bronze filled the space, preventing bubbles that would weaken the final product. This wasn't just crafting, this was industry, a leap toward mass production millennia before the assembly line. The implications are staggering. Prior to this find, historians believed standardized metal tools emerged with large empires like Rome or Qin dynasty China, where centralized workshops supplied armies and bureaucracies. But this mold, dating back to the early Bronze Age, suggests the concept of interchangeable parts took root much earlier, perhaps in the bustling markets of Mesopotamia, where demand for reliable tools outpaced the slow churn of hand forging. Imagine a workshop where dozens of these molds sat side by side, filled in a single pouring session, each yielding a blade or chisel identical to the next. Efficiency wasn't a modern invention, it was born from necessity in the smoky forges of antiquity. What's equally fascinating is the mold's material. Clay, often dismissed as fragile, was the perfect choice. It could withstand the searing heat of molten metal without cracking, and once cooled, the mold could be broken away to reveal the gleaming tool inside, no finishing required. The design even accounts for shrinkage as metal solidifies, with the cavity slightly larger than the desired tool. This level of foresight reveals a deep understanding of material behavior, gained through generations of trial and observation. And the mold's two-part construction hints at modular thinking. The same base could be paired with different tops to create varied tools, a precursor to adjustable manufacturing. Yet the mold's abandonment whispers of unanswered questions. Found in a remote cave far from urban centers, was this a master craftsman's secret, hidden to protect a lucrative trade, or was it part of a mobile workshop, cached during a journey never completed? The absence of slag or other workshop debris suggests this mold wasn't used where it was found. It was stored, perhaps waiting for a return that never came. This clay mold does more than shape metal. It reshapes history. It proves that the seeds of industrialization weren't sown in the steam-powered factories of the 18th century, but in the hands of ancient artisans who saw the future in a handful of clay. And in those precise, purposeful grooves, we find a silent challenge to our assumptions about progress, about innovation, and about the timeless human drive to do more, faster, better. Dug from the sun-baked earth of a Spanish cave, a bronze disc no larger than a palm lay caked in grime, until someone held it up to the light. The moment sunlight struck its surface, the disc transformed. Its carefully polished curves bent the rays into a searing pinpoint beam, hot enough to scorch wood or blind the eyes from a distance. This wasn't just a mirror, it was a solar weapon, a signaling device, perhaps even a ritual object, proof that ancient minds harnessed light with precision we'd associate with modern optics. The disc's engineering reveals a mastery of reflection far beyond simple vanity mirrors. Analysis shows its curvature wasn't accidental. The parabola had been calculated to concentrate light at a specific focal point. Rotate it slightly, and the beam could sweep across landscapes like a prehistoric lighthouse. Hold it steady, and the heat at its focus could ignite tinder in seconds, a priceless advantage for cultures reliant on fire. But the real genius lies in its versatility. The same disc that cooked meals by day might have flashed coded messages across valleys at dusk, its polished surface catching the last red streaks of sunset to relay warnings or summons. Then there's the military angle. Historical accounts describe ancient armies using burning mirrors to set enemy sails ablaze, a tactic long dismissed as legend. This disc proves the technology existed. Though too small to incinerate ships, a coordinated array could have torched siege equipment or blinded adversaries. The cave's location near coastal trade routes fuels speculation. Was this a pirate's tool, a smuggler's signal, or a garrison's secret weapon? Yet the disc's spiritual significance might overshadow its practical uses. Bronze, an alloy linked to deities in many cultures, often carried sacred symbolism. Could this object have been a priest's instrument, channeling sunlight to ignite ceremonial fires as divine endorsement, or a solar calendar, marking solstices when the beam aligned with specific carvings on cave walls? The disc's edge bears faint glyphs too worn to decipher, hinting at layers of meaning beyond mere utility. Its abandonment only deepens the mystery. Found alongside charred wood and animal bones, the disc might have been part of a ritual cache left as an offering to sun gods. Or perhaps it was a craftsman's prototype, discarded when newer designs rendered it obsolete. The cave's soot-blackened ceiling suggests frequent fires, a workshop where light itself was both tool and muse. What's undeniable is the disc's challenge to historical timelines. Optics like this shouldn't exist in the Bronze Age, yet here it is, a silent rebuttal to assumptions about ancient innovation. In its reflective surface, we see more than sunlight. We see a flash of human brilliance, proving that even the most fundamental forces of nature were never beyond our ancestors' grasp. Half buried in the frozen soil of a Siberian cave, a curved antler fragment seemed unremarkable at first until someone tried to bend it. Instead of snapping, the bone flexed and sprang back with unexpected force, its carved grooves acting like natural coils. This wasn't just a broken tool, it was a tension spring, engineered from organic material to store and release energy with precision that rivals modern steel. The discovery shatters long-held assumptions about ancient materials, proving that resilience wasn't the sole domain of metals. The antler's design reveals a deep understanding of material science. By selectively thinning certain sections and leaving others thick, the maker created zones of flexibility and resistance, mimicking the alternating tension of a coiled spring. When compressed, the antler's natural elasticity, enhanced by careful soaking and shaping, allowed it to bounce back repeatedly without fatigue. This wasn't accidental. The wear patterns show consistent use, as if the spring was part of a larger, frequently triggered mechanism. Imagine a snare set along a migration path, its jaws held open by this spring, ready to snap shut when an animal disturbed the tripwire. Or perhaps it powered a rudimentary drill, its recoil spinning a bone bit to bore into wood or ice. The possibilities hint at a mechanical sophistication we rarely attribute to hunter-gatherer societies. What's truly groundbreaking is the choice of material. Antler, often dismissed as brittle, becomes remarkably flexible when treated with heat and moisture, a process this artifact's makers clearly mastered. Modern engineers might use carbon fiber for similar properties, but here was a prehistoric equivalent, crafted from nature's workshop. The spring's durability defies expectations. Testing shows it could withstand thousands of cycles before failing, outperforming many metal springs of the same size. This wasn't just a stopgap solution, it was a deliberate innovation, born from intimate knowledge of organic materials pushed to their limits, yet the mystery of its abandonment lingers. Found in a remote cave far from known settlements, was this spring part of a hunter's seasonal toolkit, left behind when the herds moved on? Or did it belong to a shaman's ritual device, its mechanical magic reserved for ceremonies? The cave's other artifacts, a bundle of sinew cords, carved bone levers suggest a workspace where physics and ingenuity intersected. But without the rest of the mechanism, we're left to piece together the puzzle from this single, silent component. This bone spring does more than challenge timelines. It redefines what we consider advanced. In its flex and recoil, we find a testament to humanity's ability to see potential where others see limits, to transform a fragment of Antler into a source of power, and in doing so, bend the very arc of progress. Nestled in the jagged limestone caves of central China, a collection of smooth, oddly shaped stones lay scattered across the cavern floor until someone realized they weren't random rocks at all. Each piece fits snugly into the next, like a three-dimensional puzzle waiting to be solved. When assembled, these interlocking stones transformed into a stunning array of tools: blades, scrapers, borers, even a rudimentary axe. This wasn't just a random assortment, it was a modular toolkit, a Stone Age equivalent of a Swiss Army knife, proving that adaptability and multifunctional design aren't modern concepts, they're as ancient as human ingenuity itself. What sets this toolkit apart is its sheer versatility. Instead of carrying a dozen specialized tools, a Neolithic craftsman could transport this compact set and reconfigure it on the fly. Need to skin a hide, slot together the razor-edged scraper. Time to drill holes in bone or wood, swap in the pointed borer attachment. The pieces lock into place with grooves and protrusions so precise they require no binding, just pressure and alignment. It's a masterclass in minimalist engineering where every curve and notch serves a purpose, where patterns on the stones reveal they weren't just theoretical prototypes, they saw frequent use, their edges smoothed by countless hours of labor. The material choice speaks volumes. These tools were carved from nephrite, a jade-like stone prized for its toughness and resistance to chipping. Unlike flint or obsidian, which shatter under stress, nephrite could be resharpened repeatedly, making it ideal for a reusable system. But here's the twist: nephrite isn't local to the cave. It was sourced from riverbeds over 100 miles away, suggesting this toolkit belonged to someone with access to long-distance trade networks, an itinerant craftsman, perhaps, or a trader who repaired goods on their journeys. The implications ripple far beyond convenience. Modular design implies forward thinking, an anticipation of diverse needs and unpredictable challenges. It's the same logic behind modern disaster relief kits or space station tools, where weight and space are at a premium. But this toolkit predates those concepts by millennia, hinting at a cognitive leap we rarely associate with prehistoric societies: the ability to plan for variables, to embed flexibility into the very fabric of daily survival. Why abandon such an ingenious system? The cave's location offers clues. Situated near a confluence of ancient trails, it might have been a way station where travelers cached supplies. Perhaps the toolkit's owner intended to return but never did, claimed by conflict, illness, or simply the pull of a new horizon. Or maybe the stones were left deliberately, a communal resource for anyone passing through. The absence of similar finds elsewhere suggests this technology was either exceptionally rare or routinely dismantled and repurposed, its components scattered like echoes of a brilliant idea. This modular toolkit does more than challenge timelines. It redefines how we view innovation. In those interlocking stones, we see the birth of a philosophy that the best tools aren't just functional, but fluid, capable of evolving with the needs of their users. It's a reminder that the human mind has always thrived on adaptability, turning rock into possibility and isolation into interconnectedness. And somewhere in that quiet cave, those stones still whisper the same lesson. The future belongs not to the strongest tools, but to the most versatile minds. These 24 tools aren't just fragments of the past, they're fragments of possibility. Each one shatters the illusion that progress moves in a straight line, revealing instead a web of ingenuity spun across time and geography. Take the crystal lens and the Baghdad battery, separated by continents and centuries, yet both hinting at a fascination with light and energy, or the bone tension spring and the threaded stone bolt, proving that mechanical brilliance didn't wait for the Industrial Revolution. These artifacts whisper a truth we've long ignored. Innovation isn't about who gets there first, but about how many times humanity rediscovers its own potential. What's humbling is realizing how much we've lost. The petrified wood pulley from Indonesia and the modular toolkit from China suggest entire schools of knowledge that vanished without a trace. Imagine the libraries of tactile wisdom, craft techniques, material sciences, astronomical insights passed hand to hand until some final, untold crisis silenced them. These caves weren't just hiding places, they became accidental time capsules, preserving ideas too advanced for their eras, waiting for us to stumble upon them and question our assumptions. And that's the real magic of these discoveries. They don't just rewrite history, they rewrite our sense of what's possible. The echo-enhanced horn from the Andes and the perforated sound stone from Malta remind us that ancient people didn't just survive, they experimented, they played, they sought beauty in resonance and rhythm. The glass-lined crucible from Egypt and the metallic adhesive from Greece reveal a relentless drive to push materials beyond their limits, to forge connections both literal and metaphorical. But the most tantalizing question remains, what else is out there? For every tool we've uncovered, countless others likely lie buried in uncharted caves, submerged in rising seas, or crumbling beneath modern cities. Each one could hold the key to another forgotten chapter, another stroke of genius waiting to be recognized. Maybe there's a cave somewhere with the remnants of an ancient chemical battery, or a textile loom so advanced it rivals modern machines. The only certainty is that we've barely scratched the surface, so the next time you hear about a mysterious artifact pulled from the earth, don't just think of it as a relic. Think of it as a message, one that traveled through millennia to remind us that human creativity has always burned brighter than we assume. And if these tools teach us anything, it's that the future of discovery lies not just in moving forward, but in looking back with fresh eyes. Who knows what other marvels are waiting in the shadows, ready to rewrite the stories we thought we knew. The past isn't finished speaking, and neither are we. Let's keep listening.